Hello everyone. Today I am discussing a topic that is quantum number. So before knowing the quantum number, I am giving an example. कि just as to search, if you just search a particular person in this world, four things are needed. First, the country to which the person belongs. Second, the city in that country to which the person belongs. Third, street in the city where the person is residing. And fourth, the house number. Similarly, four identification number are required as to specify a particular electron in an atom. And these identification numbers are called quantum number. And these are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Principal quantum number is denoted by small n, azimuthal quantum number is denoted by small l, magnetic quantum number is denoted by small m, and spin quantum number is denoted by small s. So first we know about the principal quantum number. It specifies the location and energy. Location and energy. Location and energy of an electron in an atom. The energy of an electron and its distance from the nucleus for hydrogen atoms are En, that is calculated as En is equal to minus 2 pi square m e to the power 4 by 4 pi epsilon naught whole square n square h square, where 4 pi epsilon naught is permittivity factor, and that is epsilon naught. The value of epsilon naught is 8.854 into 10 to the power minus 12 Coulomb square Coulomb square per kg per Kelvin per meter cube second square. And m, that is mass of an electron, m is 9.1 into 10 to the power minus 31 kg. E, that is charge of an electron, that is 1.602 into 10 to the power minus 19 coulomb. H is Planck's constant, and that is 6.626 into 10 to the power minus 34 joule second, and n is equal to 1, 2, 3, so and so on. That En, this En is the nth electronic level, and the energy of an electron in an atom increases with the value of the principal quantum number. In this formula, if you are putting the value of these all, that is pi, m, e, 4 pi epsilon naught and h, you will get En is equal to minus 2.177 into 10 to the power minus 21 by n square kilojoule per atom, or En is equal to, in mole, it is minus 1312 by n square kilojoule per mole. It's a very important formula. So whenever you are calculating the energy level of each cell, that is K cell, L cell, M cell and N cell. Here you can see this is the first cell, second, third and fourth, and then it's a nucleus, and the nucleus to the atom electrons that is residing in first cell, that is K cell, it is 53 parts million, the electrons revolving around the nucleus in first cell. Mean it is the energy level that represents the relative distance of the electron from the nucleus. The relative distance from the nucleus mean the relative distance of the electron from the nucleus in first cell, that is K, it 53 pm, whereas for second it's a 211 parts million, 211 parts million. For third cell, that is if n is equal to 3, it's a 473 parts million, 400 pm, 473 pm, and for fourth it's a 845 pm. So if you are calculating the energy of the first cell, that is for n is, if n is equal to 1, here it will be minus 1312 kilojoule per mole. For E2, for E3, E4 and E5, similarly for E5, it is the calculated energy value for various energy level in a hydrogen atom. Mean it is E1, E2, E3, E4, that is energy of an electron of an atom increases with the value of principal quantum number. Mean you can observe when n is equal to 1, the energy value of first cell, that is first energy cell, is minus 1312 kilojoule per mole. Similarly for 2, for 3 and 4, you can observe the energy of an atom, you mean the energy of an electron, an atom increases with the value of the principal quantum number. Is it clear? Now for second, that is Azimuthal quantum number, that is denoted by small l. It have integral value from 0 to n minus 1. Mean each value corresponds to the energy of subcells in which electrons is located. The subcells are designated as S, P, D and F. Let us see if what's the value of L in mean azimuthal quantum number, or it is also known as angular momentum quantum number. Value of L, second designation of subcell and a spectroscopic term. Mean if L is equal to 0, L is equal to 0, it will be S, and this word comes from a spectroscopic term is SAR. If L is equal to 1, it's a P. A spectroscopic term is principal. L is equal to 2, it's a D, that is diffuse. It is a spectroscopic term, whether we are designated a subsets, that is S, P, D and F, and when L is equal to 3, it's a F, that is fundamental. So when L is equal when N is equal to 1, now you can observe, or you when N is equal to 1, L equal to 0, because this value lies from 0 to n minus 1, yani 0 to n minus 1. Here you are putting the value of n is equal to 1, it will be 0. So if n is 1, L will be 0. Is it clear? N is equal to 2, L is equal to 1, n 2 minus 1, 1. N is equal to 3, L is equal to 2. N is equal to 4, L is equal to 3. It means it has only one value when n is equal to 1. That's why it has only one S. N is equal to 2. That is L is equal to 1. 1 means it's included 0 to n minus 1. So it will be 0, 1. It has two value, that is 2S and 2P. Similarly, n is equal to 3. L will be 2. The L will be 2 will mean it's 0 to 2. So you can write here 0, 1, 2. Mean it has 3 value. That's why it's a 3S, 3P and 3D. N is equal to 4. L will be 3. The L will be 3 mean it 0 to 3. So it will be 0, 1, 2, 3. So it has 4S, 4P, 4D and 4F. Is it clear? Azimuthal quantum, for azimuthal quantum number, the value lies between 0 to n minus 1. So we are putting the value of n 1, 2, 3, so and so forth, and the value lies between 0 to n minus 1. So this L indicates कि it has, if n is equal to 1, L is 0, it will be only one S. Similarly, for all n is equal to 4, it has 4, mean it's a 3. So 0, 1, 2, 3, there are 4 value. So it will be 4S, 4P, 4D and 4F. This azimuthal quantum numbers determine the shape of an orbitals. And the quantum number also represents quantized value of angular momentum of an electron in an orbital through the expression, that is L is equal to L plus 1 under root H by 2 pi. So for this formula you can also calculate the value of azimuthal quantum number, and this is second quantum number, that is azimuthal quantum number. Is it clear? Next is third is magnetic quantum number. Magnetic quantum number. It is denoted by small m, and it can have all integral value from minus L to plus L. Minus L2 plus L through 0. 0. So this for a given L value, there are 2L plus 1 value for M. Mean if you are what will be the value of magnetic quantum number? It lies between minus L2 plus L. So a given L value, there are 2L plus 1 L value. It means it's a minus L plus 1 minus L plus 2, so and so on. 0, plus 1, plus 2, plus 3, so and so on, L minus 1 and L. It means value lies between minus L to plus L. Mean each m value correspond to a specific orientation of the orbitals in space. Let us suppose for s orbital. Value of L will be 0. In earlier Azimuthal quantum number already discussed, when L is 0, it's a s orbital. So s orbital mean here s orbital, that mean ki L, value of L is 0. So if value of L is 0, m will be 0. Mean only one orientation possible. For p orbital, L is equal to 1. So m will be minus 1, 0, plus 1. Here value lies between minus L to plus 1. So L is 1. That's why L is minus 1 through 0, 0 and plus 1. There are 3 values. Mean 3 orientations are possible. So that's why 3 orientation, that is for P, it's a Px. That's why we are writing Px, Py and Pz. 3 orientation at 3 coordinate axis. It's a Px, Py and Pz. If for d orbitals, L is equal to 2. So m will be minus 2, minus 1, 0, plus 1 and plus 2. There are 5 values. It means 5 orientations are possible. What are they? Or in these 5 orientation, that is dxy, dyz, dxz, dx square minus y square and dz square. 5 orientations are possible. It depends upon the value of n. That's why the 5 degenerate orbital we are writing first dxy, dyz, dxz, dx square minus y square and dz square. Similarly for f orbitals, L will be 3. So m will be minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. There are 7 values and 7 orientations are possible. That's why for f orbital, these 7 orientations are f x square minus y square, f y x square minus y square, f z x square minus y square, 1, 2, 3, f x y z, fourth, f z cube, f y z square and f x z square. These are the 7 orientation of f orbitals. Is it clear? So for s orbital, p orbital and d orbitals, the value mean the orientation, that is the specific orientation of the orbitals in the space are this. Clear? And next, that is discussing the 4th quantum number, that is spin quantum number. 4th quantum number is spin quantum number. Spin quantum number. It is denoted by small s. That means spin value. Spin value you are going to calculate. You can calculate mu s is equal to s plus 1 under root h by 2 pi. So spin is either the value of spin is plus half or minus half, plus half or minus half. Plus half mean orientation is clockwise direction, and minus half orientation is anti-clockwise direction. It means whenever you are putting the electrons in orbitals like this, it means there is a opposite spin, yani plus half, one is clockwise and another one is anti-clockwise. It means paired spin, that is opposite spin. So overall the value will be 0, plus half and minus half, the spin value will be 0. If electrons are paired like this or this, it means it's a parallel spin, and parallel spin means either it's a plus half or minus half, because of both are in same direction. So the magnitude of the spin angular momentum is a vector quantity. It can have two orientation, and you can see an orbitals can accommodate two electrons having opposite spin. That's why here the S value for this is equal to 0. Now overall I am taking an example whenever you are going to write the all possible quantum numbers that comes in your examination. So let us suppose if there is a one configuration for hydrogen atom, it's a 1s1, and question is write the all possible value for quantum number, that is n, l, m and s. So here for 1s1, what will be the value of n, l, m and s? N, here n is equal to 1. If n is equal to 1, L will be 0. L is 0, M is 0, and M is 0. S that is 1 electron. Either it's a parallel or anti-parallel. It means it may be plus minus half. Is it clear? Because always if n is equal to 1, L will be 0, or L is 0, M is 0. Second example I am just discussing, that is, let us suppose it's a 3s1. N is equal to 3. L will be 3 or 0? 0, because for S, L value will be 0, not it will be 2. It never be 2, because for S, L value always 0, and L is 0, then M will be 0 and S will be either plus minus half. For next example, 3d5, N is equal to 3, L is equal to 2. For D, 2 value, that is M will be, what will be M? Because N is 3, L is 2, then M will be minus 2, minus 1, 0, plus 1 and plus 2, 5 value. It lies to minus 2 to plus 2. L will be minus 2 to plus 2. That's why M has 5 value, and you know very well D has 5 orientation, that is dxy, dyz, dxz, dx square minus y square and dz square. And what will be the S value for D5? It's a D 1, 2, 3, 4, 5. Half. Either it's a plus half or minus half. You mean 5/2. So there are many examples in your book. You can easily now you are able to write the all possible value of quantum numbers, that is for n, l, m and s. I think topic is clear. If you have any queries, any questions regarding quantum numbers, then you can write comment in my comment box. Thank you.